miles from Earth in what we call the Lagrange point, where it is in an orbit that helps it have a good view of away from the sun in order to get good views of the galaxy.
Now, what can we expect to see in the days coming?
We can expect to see more images from the James Webb as it continues to now begin its scientific mission. So now it is doing the missions of universities, scientists, engineers to help discover different sections of our galaxy, different sections of our universe that could be explored to see what we can see.
Now, water was detected via the telescope just today. Tell us about that.
So with it being an infrared telescope, it has the ability to see the changes in the light that comes through particular atmospheres. And so water has a particular reflection or image that it gives off. And that's what this telescope gives us the ability to see, to predict what is in the atmosphere of exoplanets. That is what we're getting from this telescope.
Now, you talked about the Colorado connection. Tell us a little bit more about that again.
So the mirrors were developed here in Colorado as a part of Ball Aerospace, in which they've created the beryllium mirrors, which were then integrated by Northrup Grumman. Northrop Grumman has over 400 engineers here in Colorado, but the actual system integration and engineering was done in California at El Segundo at Space Park. So that is what we're talking about. University of Colorado assisted with some of the development. It is a full connection within our state.
Talk about the cost to put something like this out into space and the manpower required to do this type of job.
So you're talking about cutting edge technology. The mirrors, the cooling. Remember, there are portions of this telescope that are cooler than anywhere else that you'll find in the universe. So this required a lot of new technology and development. So it had a lot of research and development in order to really help develop this, as well as the launch costs to get it out to space. So definitely great work done by all.
And the cost?
Over $10 billion.
Over $10 billion. How does the James Webb Telescope compare to the Hubble telescope?
So you're talking about it'll be able to see more than the Hubble could, 100 times more. You're talking about an ability to see planets at greater detail. You're talking about an ability to make determinations about atmospheres. The scientific jump that we're taking from the Hubble can't be compared.
Talk about the impact on mankind this telescope is going to have.
You can see it here in the Denver Museum of Nature and Science. You can see it in the way that kids are wanting to know more. You can see it in their way of understanding that the universe is so grand, how humongous it is for understanding what is happening in the world. That is what we're gaining from this.
And what is it that we hope to pass on to future generations via this telescope?
Knowledge, inspiration, wanting to know more. That's what we're passing. To know that that someone should be developing the next telescope that can see even more and discover more for all of us.
Now, how does this compare as to landing on the moon, going to Mars, sending other Voyagers to other planets?
This is that next step of our technological generation. This is where our first step of the James Webb being deployed. Now we're going to go back to the moon. We're going to the Mars. This is that great jump that we are taking in order to explore for everyone.
Thank you so much.